So those are the three projects. The one thing, and unfortunately the colours don't seem to come out very well, but across the top here we have what's called storage policy-based management. Now this is, what you can think of this as is VASA and profile-driven storage 2.0. Do many of you use VASA, the storage awareness APIs? Okay, and do many of you use profile-driven storage? Okay, so now we brought those out in VMware 5.0, and I'll be the first to admit that they had limited uses. There were a certain amount of restrictions around them. In particular, the fact that you could only surface up single capabilities per storage device, and so on. What we're doing with storage policy-based management is we're taking that to the next level. So we're moving VASA and storage profiles up to a new level. And when we talk about vVols and we talk about vSAN, you'll see what I mean by that. So that's essentially what we're doing. And what we want to do essentially is, as it says here, the vision is basically to provide storage services and SLAs for all applications that are running in your virtual machines. It doesn't matter what the underlying storage type is. What I mean by that is that we will now define in a policy what the requirements are of the application running in the virtual machine needs from a storage perspective. So do we want to do thin provisioning? Do we want to do deduplication? Do we want to do snapshotting? Do we want to do replication? Now what we do is we just put that into a policy, push that down to the storage layer, and let the storage layer take care of the instantiation of the VMDK objects based on those requirements. So we'll drill into that in a bit more as well. So this is typically what we have right now, I guess. We typically have our vSphere clusters. There's some interconnect, and then we have our SAN or our NAS at the back end. Our SAN and our NAS storage presents a bunch of data services to us. So these could be things like the ability to do snapshots, the ability to do replication, or whatever the case may be. So we want to introduce some additional services such as vFlash, and we're seeing an awful lot of proliferation of flash in the data center right now. I'm sure those of you who are following the storage news will be aware of announcements from EMC with their VM cache recently, and NetApp have also had a release. QLogic, Mount Rainier. You know, if you come across that QLogic, we're actually here. I don't know if you managed to get out and see them, but they have a very interesting product which combines the HBA with the flash in a single PCIe card, which is quite a unique product actually. So there's a lot of things happening in that flash space from a host-based perspective. And then, of course, we have a whole proliferation of appliances that can sit out on our data center somewhere, providing all sorts of services. So, you know, there's Atlantis, who do, you know, I/O acceleration. There's a whole bunch of others out there. So what it's all about is, without you having to worry about configuring all of these items on a per VM basis or even on a per data store basis, why not provide a catalog of these services that you can leverage when you define your policy? So if you need deduplication, or if you need thin provisioning, or if you need snapshotting or replication or whatever, our vision is that you will just populate a policy associated with the virtual machine. And that policy, when the virtual machine is created, is pushed down to the storage layer, which can encompass all these data services, and the virtual machine requirements will be met using whatever data services are available to you. So does that kind of make sense in some respect? Good, good. So that's what it's all about, basically just having this data services catalog. And so as you go ahead and you provision your virtual machines, you set aside, you select your requirements, put them in the policy, and it doesn't really matter where you're leveraging the service from, as long as it can meet the requirements of the policy that you set aside for that virtual machine, then these data services can reside pretty much anywhere in your infrastructure. So hopefully you get the idea. So that's the big picture. Okay, let's drill into the specifics and let's have a look at what we're actually doing around that now. So there's three things that we're doing. So as I said, we have the initiative around local storage. That is the vSAN product, or the distributed storage product. We have the initiative around vFlash, which is leveraging SSDs or PCIe flash devices and assigning cache to your virtual machines. And then, of course, we have the shared storage project as well, which is vVols, or virtual volumes. So we're going to start off with vFlash. Now, to be very honest, we've done very little around SSD or flash up until now. We had a few features for sure. We had the swap to SSD feature, just to speed things up in case you were swapping to disk. And then in 5.1 we introduced this I/O device monitoring feature, which also allowed you to look at SSD statistics and so on. But to be perfectly honest, we hadn't done an awful lot. And so what we wanted to do is introduce a mechanism where we could leverage SSDs and use them as a resource in much the same way as we use CPU and memory resources right now. So that's what we're hoping to achieve with vFlash. So there's a whole infrastructure that we're going to put in place that not just allows us to create our own caching algorithms, but we want to open this up to third parties as well. So we want, we want to have a partner program where other flash vendors will plug into the vSphere environment. But on top of that as well, we wanted to have flash that would allow us to do core vSphere features, like be able to do vMotion, be able to implement DRS clusters and HA clusters as well. We know there's a lot of flash devices out in the market at the moment which can accelerate virtual machine I/O, but unfortunately they don't integrate completely to allow things like DRS, HA, and vMotion to operate. So the challenge we had is that, well, basically we haven't done anything in this area before, so it was starting from the ground up, and there's no framework available either through our third parties. So with that in mind, we implemented this vFlash infrastructure. So the vFlash infrastructure is essentially allowing us to take SSD devices, PCIe flash devices, and build a pool of these flash resources, and then carve up that pool and allocate flash to our virtual machines on a per VMDK basis. So that's essentially what vFlash is all about. Now, we do have the whole infrastructure, so this allows our third-party partners to also plug in here as well. Think of it as like the pluggable storage architecture, the PSA that we have for our I/O stack. And so while we ship with some native plugins, the native multipath plugin and so on, we also allow third parties to plug in there, like EMC's PowerPath. So we're approaching this in a similar fashion, so that we have an infrastructure where we're going to ship you with some default flashing algorithms, but it's going to be open and available for other third parties to plug in as well. So we're going to ship with a default VFC module. Initially, it is only going to be a read-only caching module. So it will only cache your reads. So your writes will still be committed directly to disk. Reads will accelerate. Doing write caching is a lot more difficult than doing read. So, but it's in our roadmap. We're thinking about doing it further down the line. The other thing is that this is what we're calling VM transparent. In other words, your virtual machines will leverage the cache without knowing that it's doing so. We're also thinking about doing VM aware caching. This is where you will carve up a VMDK and present it as a disk directly into your virtual machine as well. But that's something that's a way down on the roadmap as well. So initially, it's a VM transparent cache, read-only cache that we're looking at introducing. So it's pretty straightforward. As I said, we just take the SSD or the PCIe flash devices that you have available to your host. You put them into this flash pool, And once they're in the flash pool, as you can see here, you can then go ahead and start carving them up and assigning portions of this flash to your VMDKs. So it can be assigned on a per VMDK basis. So if you have a virtual machine with multiple VMDKs, maybe some of those disks don't actually need caching, others maybe do. So you can divvy it up that way. So once you have your cache pool, you can go in and edit it and make a reservation, as I said, on a per VMDK basis. Now, the other thing here is that the flash module is VFC. That's our default one. But you can imagine that if you had other partner plugins here, you could just go to the drop-down and select the appropriate plugin there. Block size, the block size should be set to match the application block size. And so we will work on putting out some collateral around what are the appropriate block sizes to use with certain applications and so on when we do get around to launching that. But that's essentially the only three things that you need to set up. And then once that's been set up, you can see the vFlash cache summary will be displayed in the virtual machine summary tab. So it's as simple as that. So the one nice thing about it is that it's fully functional with core vSphere features like vMotion, the RSHA. What you can decide to do is when you do a vMotion operation, it will give you the opportunity of keeping the cache with you. So you can actually migrate the cache along with the data, which means that your virtual machine is already warmed up from a caching perspective when it reaches its destination. The other option as well is that if the migration is of the utmost importance and you're not too worried about the warming up at the destination, then you can choose to discard the current cache contents and leave the virtual machine warm up at the destination. So that might be something you might choose to do during maintenance or something like that, where actually nobody's actively using the virtual machine. So the objective is just to migrate it off the data store as quickly as possible, or off the host as quickly as possible. So that's vFlash in a nutshell, and I know we're kind of short on time, so I'm just going to go straight on and we'll do a Q&A at the end, if that's okay. All right. So the next thing I want to talk to you about is vVols. Now, we have been talking about this for a number of years already, and this is the initiative that's going on to make virtual machines first-class citizens in the storage world. So you might ask, why do we want to do that? So right now, when we're dealing with virtual machines and the storage for virtual machines, yes, they have VMDKs, but the VMDKs are resident on a LUN or a data store. When it comes to things like snapshots from the array side or replication, we're typically dealing with the whole LUN in those cases. So we may have to snapshot the whole LUN. And definitely in the case of Site Recovery Manager, when you're trying to set up a DR solution, you're replicating the whole LUN as well. And so that's additional management overhead for you guys, because you got to figure out, well, the virtual machines that I want to replicate, well, I should put these on the LUN that is replicated. And these virtual machines that I'm not concerned about replicating, I need to find an alternate LUN to put those on. So what we want to do is make the VMDK, that storage object, an actual object on the array itself. And that's what vVols is all about. Because then when it comes to snapshots, you're just snapshotting that VMDK. When it comes to replication, you're just replicating that VMDK. And that's what the initiative is all about. Huge challenge, of course, because this is not something that VMware can just develop. We certainly can create the APIs, but then we need our storage array partners to go out and implement what needs to be done at their end. And that's a huge undertaking. Okay? Because we're talking about a brand new object on the storage array, a VMDK object now. So right now, just to reiterate what we're doing, essentially when we want to do creating VMDKs or creating snapshots or replicating and so on, this is all done at a LUN level. The LUN plays a significant part in that operation. What we want to get to is the point where we don't have to worry about these LUNs or mount points or whatever. And so when we instantiate a VMDK or we snapshot a VMDK or whatever, we are creating a brand new object just for that virtual machine or just for that virtual machine disk file on the storage array. So that's what we're aiming towards. So this is where SPBM, the storage policy-based management, comes to the fore once again. So this is where we're going to create profiles. And in that profile, associated with the virtual machine, when we create it, we're going to put the set of requirements for that VM around snapshots, around replication, maybe around dedupe, maybe around thin provisioning. Whatever the storage characteristics we want for our VM decay, we're going to place into this policy. And this policy, when the virtual machine is created, is now pushed down to the storage array. So this is what I was talking about at the very beginning. It's the profile-driven storage and the VASA 2.0 features coming to the fore. So now what we do is once we have a virtual machine that we wish to create, we associate it with a profile, push it down to the storage layer, and get the storage layer to instantiate that VMDK object based on our requirements. So whether it needs to be replicated or snapshot capable or whatever. So how do vSphere hosts now access these objects? So this is the next big thing. And are we implementing some kind of new protocol to allow us to achieve this? And how do we scale it out? Because we do have a number of scalability restrictions at the moment, right? It's 255 LUNs per host, 1024 paths. And so we have customers who are already hitting these limits now. So will vVols help them? Well, this is probably what most of you have right now. VMFS, clustered file system, but in order to leverage vMotion and DRS and so on, it needs to be shared to multiple hosts. And then obviously we want to have it highly available. So if one path fails, we want to be able to fail over to an alternate path. So you end up with a big mesh of connectivity. Does this look familiar? Yeah. So what we want to get to is a more scalable mechanism. And so we're introducing this new object. And this is what we're calling the protocol endpoint. I think for those of you who visited VMworld, I think it was called a demultiplexing device or something as well. It has had various names. But the PE or the protocol endpoint is still just a SCSI LUN, or it's an NFS mount point in the case of NAS storage. And so what we'll do then is that we just need to map this single protocol endpoint to any of the hosts that wish to create virtual volumes. So it's almost like a gateway device, essentially. But it does a little bit more than that. In order to scale up to the many thousands of virtual volume objects here, we've actually had to change the SCSI addressing scheme. SCSI addressing scheme now is the protocol endpoint ID plus an offset ID for each of the VMDKs. Now, this is T10 standard stuff. We're not changing anything here. T10 already allows us to do this new SCSI addressing. But the great thing is that we're no longer limited to 255 devices. We are now able to scale to many thousands of VMDKs or virtual volumes. The other nice thing is when it comes to multipathing, your protocol endpoint is the only object that you need to worry about. So you set up your multipathing to your protocol endpoint. So you select your correct SATP or your round robin if you so wish. And all of the virtual volumes that are backed by that protocol endpoint inherit whatever settings you put against its protocol endpoint. So if you set round robin here, each of these VMDKs is accessed on a round robin basis. So that's how we're achieving this new virtual volume feature. There was one other thing I did want to bring up around that, and this is about the how do you know how much space you have available? So right now what we do is on the array we build a pool or a RAID group or whatever the naming terminology is, and from that we carve up LUNs, and then we present those LUNs to our hosts, right? In the case of vVols, we stop at the creation of the storage pool or the creation of the RAID group or whatever you want to call it. And that RAID group size, that RAID group characteristic or that pool characteristic is surfaced up to vSphere. So within vSphere, you will be able to see an object representing your pool. And from there, you just build your VMDKs, and as you're creating VMDKs, you will see the available space on the pool reduce. So you can still have capacity monitoring, management, and so on available to you. Okay. So PEs, they're essentially the only LUNs or mount points that are presented to the hosts. So even if we stick at the 255 LUNs limit, you can still have up to 255 PEs with, as I said, many VMDK or virtual volume objects hanging off the back end. Okay, so that's bringing me on to vSAN, which is, I suppose this is the feature or the product that's, I guess, generating most excitement. Certainly at VMworld it was anyway. We've been calling it different names. It has gone through a name of distributed storage for a while, but I think we might be settling on vSAN. It seems to be what most people know it as anyway. So what's that all about? So vSAN is where we're going to take the local storage of your ESXi hosts, and through another layer of software that's going to sit on your ESXi hosts, we're going to be able to build what we're calling a distributed vSAN data store, which traverses all of your ESXi hosts. So there's no SAN connectivity needed, there's no NAS connectivity needed. You just need local storage and some new features that are coming down the line from VMware. So there's a couple of things around the requirements. You will need to have at least one SSD in each host, and this is used for a write buffer and a read cache. You will also need 10 gig network interconnect between the hosts as well. But the very cool thing is it's fully integrated with DRS, HA, vMotion. So you can have a 32 node local storage cluster, which is creating a distributed data store for your virtual machines to move about. And so you can still leverage all those core vSphere capabilities like HA and DRS and vMotion. So it's essentially, as it says here, converging compute and storage, fully managed by vCenter as well. And how you'd set it up is pretty much exactly the same way as you would set up a HA or DRS cluster in your vSphere UE. So you just, from a drop-down box where you have your HA cluster, DRS cluster, you will now have a vSAN cluster available to select as well. And so obviously it'll do a whole bunch of preliminary checks. So it's going to check that you have your networking set up correctly and so on, and that you have local storage and all the rest of it. The one other nice thing about this is that you can have hosts that are compute-only hosts participate in the cluster. So by that I mean you can have stateless ESXi hosts that have no local disks that can be part of the cluster but can still leverage the distributed data store. So that's really quite a neat thing. So yes, and so the other thing, of course, brings me back once again to SPBM, the storage policy-based management feature. So again, just like we talked about in the vVol section, you are going to populate this policy from the point of view is, how available do you want the virtual machine? Some performance aspects of the virtual machine. How much caching do I want to give to the virtual machine? You will put all this information into your policy, and when you instantiate the virtual machine, the policy gets pushed down to the vSAN layer, and then that instantiates the virtual machine disk file across the vSAN distributed storage data store based on the requirements that you put into the policy. So from the point of view of performance, it might stripe your VMDK across multiple spindles. From the point of view of availability, you might end up with replica virtual machines across multiple hosts in the cluster, those kind of things. So let's have a little bit of a look at the architecture. So this is what we're terming RAIN, not RAID. So RAIN is, it's a reliable array of independent nodes. And so what we're saying here is that you can have a node failure. And when I say node failure, it might be some disk failures or whatever the case may be, but maybe a node is taken out of the cluster. It should not impact your virtual machines in any way. Now, I say that with the caveat that that's as long as you have set up a correct availability profile. If you've deployed virtual machines and you've said, I don't care about availability, just make me one instance of the virtual machine, well then, obviously, you may be impacted. But if you've gone through the policy and you've set availability for your virtual machines to tolerate a certain number of host failures, just like we have HA tolerating host failures, then if a node fails in vSAN, your virtual machines will continue to run. Does that make sense? And so the technology, or I suppose the reference is RAIN, which is, as I said, reduced reliable array of independent nodes. So it's a combination of SSD and spinning disks. There has to be at least one SSD and one spinning disk, but obviously we would expect that there would be a lot more spinning disks in each of the nodes as well. So again, we're going back to VASA. VASA, now the next release of VASA is coming into its own. VASA, when we had it previously, these are the APIs for storage awareness. They would surface up capabilities from the storage array about the data stores. VASA 2.0 now does a whole lot more. Not only does it surface up the capabilities of the data store, and we're talking about multiple capabilities, but it's also involved in being able to push the requirements back down to the storage array as well, or to the vSAN layer. So VASA 1.0, one directional, single capability. VASA 2.0, multiple capabilities and bidirectional as well. So I'll talk a little bit about the storage service classes. This is really just a new name for profiles. So as I said, when you instantiate a virtual machine on vSAN, you will first of all be creating profiles or storage service classes. I don't know why they made the name change, but they did. But it's essentially profile-driven storage, as we know from vSphere 5. And into that policy, you will put the requirements around performance, around availability, around caching. You will associate that policy with the virtual machine when you deploy it on vSAN, and then that all gets pushed down to the vSAN layer and gets instantiated. So yeah, so as I said, the VMDK, it is instantiated based on the contents of the policy. Okay. So what does it look like? So this, have many of you used the web client yet? Okay, so a lot of you might be familiar with it already. This is the new web client, not the C# client. And so vSAN is configured through the web client only here. And so I have 3 nodes, I have 3 ESXi hosts in my cluster, and I'm just coming out into my cluster settings. You can drop down here and we have, I know it's not very clear, but hopefully you can see it. But essentially it's just the general tab here in vCloud Distributed Storage. That name will probably change again, by the way. And so you can just go on and turn it on. And so the only thing you have to make a decision about is this automatic or manual mode for adding disks to the cluster. If you leave it in automatic mode, what vSAN will do is it will go out and look for all the disks that are in the cluster and will automatically just add them in. And so they'll be available to you in this one large vSAN distributed data store. If you put it into manual mode, it won't add the disks, so you just go in and add them afterwards. There's a reason for doing that, because we have this concept of disk groups where you can set up multiple disk groups per host if you wish. It's probably getting into too much detail, but the point is it's simple to set up. It really is just a couple of clicks to get vSAN configured. Because we're shipping all the required components on the ESXi host. So there's no VIBs to install, there's no patching, there's nothing like that. Your ESXi host will ship with the components that are required to set up vSAN. I'm not saying when it is going to ship, okay? But I'm just saying when it does ship, it will have everything that's there. So it's just a matter of going into vCenter then, building your cluster and enabling vSAN. So once that has been done, once you have enabled vSAN, a bunch of things happen. The main one is that you end up with this very large vSAN data store, which is an amalgamation of all the local storage from all the ESXi hosts that are in your cluster. Now, that will be capable of doing certain things. Depending on the number of spindles you have in the cluster, that will give you the performance that you can achieve from your virtual machines, because you'll be able to do so much striping. Depending on how many hosts are in your cluster, that will determine how much availability you can give. You know, how many host failures can my virtual machine tolerate? These kind of things. The SSD sizing then, that will tell you how much caching you have available. So all of these properties will be surfaced up once you have created your vSAN cluster. Once you have these properties, you can then go ahead and build your storage classes, or your profiles, if you want to call them that. So here we get, let's say, the configuration maximums from your vSAN. It'll tell you what you're able to tolerate from a failure perspective, you know, how many IOPS perhaps you might be able to achieve, something like that. But once you have these capabilities, you can go ahead then and start defining your policies. And this is a big difference from profile-driven storage. Profile-driven storage was a single policy associated with a data store. Here, we have one large data store, but we can create multiple policies. So we can have virtual machines instantiated with multiple different policies on the same data store. So that's another big change from what we had previously. And you know, so you might have some virtual machines that maybe not quite so important to you. So maybe you'll have it tolerate a single host failure, but maybe other virtual machines, very important, you might have them tolerate more host failures. Some virtual machines, the application may not need quite the performance, so you might put your striping value or your IOPS value reasonably low. Other virtual machines may have a high performance requirement, so their striping factor or their IOPS requirement you can set very high. But the point is, they will all be pushed down to the same data store. vSAN will take those policies, and then it will decide how it's going to lay out your VMDK for you. Does that all make sense? Okay, great. And so just kind of finishing off here, that's just reiterating what I was saying, is that now we have a data store where there are multiple objects instantiated. So we might have, I'm going with the gold, silver, bronze thing again, but hopefully you get the idea. And so all of these are what we call our storage class. But for want of a better description, they're the profiles that we had previously. And so I might instantiate a virtual machine. I would select the policy called silver because it has a certain performance requirement and a certain availability requirement, which is what I want for my virtual machine, and that just gets instantiated as a VMDK onto my distributed data store. So it's just really summarizing. But so hopefully, what I wanted to do is give you an idea of what we're trying to do from the software-defined storage perspective. And I know there's a lot of waffle around that, but hopefully having seen the storage initiatives that we're working on internally at VMware will give you an idea of how we're trying to make that a reality. And so that's pretty much all from me. Thanks for your time, and we can do a Q&A now. So.